Hey everyone, welcome back to the channel. Today let's solve this some problem in this video. It says given an array of integers nums and an integer target, return indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. Okay, so we will be provided with an array of numbers and we need to pick two numbers from that array which will be add up to the given target. So let's go through the examples. In the example 1, the nums provided is this one 2, 7, 11, 15, and out of them we need to pick two which will add up to the 9 in this case. So as you can see, like here you can see, right, 2 plus 7 will be 9 and that is the only solution we have in this particular nums array. As mentioned in the description, there will be only one solution exactly, nothing more, nothing less. So we won't run into the edge cases like no solution or multiple solutions. We will be guaranteed that there will be one solution, and that solution, by looking at it, we can say 2, 7, and the corresponding indices are 0, 1. So that's what the expected output in for the example 1. Let's check example 2. Here 3, 2, 4 are the nums and the target is 6. You can see 2, 4 will be added up to be the target. So that's why their corresponding indices 1, 2 are the output. And you might think there is the 3, right? We can add that up with itself and that will be equal to the target 6. 3 plus 3 is 6. But that's prohibited. It's mentioned here. You may not use the same element twice. Example 3. Here also there are two elements 3, 3 and the target is 6. So obviously when we add the first 3 with the second 3, the target is met. So the indices are 0, 1. So now let's solve the problem using brute force approach first. Then we will make use of hash map to gain a better performance. Let's write the brute force solution first. For that, let me declare a res variable which will store an empty array as of now, but it will be used to store the actual indices which are required. We will return this res at the end. Now in the brute force approach, let's go through the array in a step-by-step manner. In the first step, we will try to find out the element A, so which will be one of the elements which are required. In the second loop, we will be finding the element B. So this element A and element B, when added up, will be equal to the target. So for the first loop, let's declare I as the index. It will run through the complete array. Here for each I, we will be looking into the array again to find out a element B which would satisfy the given condition. Here the condition is element A plus element B equal to target. So let's loop through the array again. So we are looping through the array and we are getting hold of I comma j indices, and let's try to see if these particular elements which are represented by the indices I comma j would satisfy the condition or not. For that, let's try this equality. If this satisfies, then let's store these index values in the res. This ideally should work, but it will fail. I'll show you when it will fail. Yeah, if you can see here, it's failed for test case 3, even though it's passed for test case and test case 2. For test case 3, it failed because here it picked the index 1 twice, violating the description here. So to fix that, we will do one thing. For starters, we can just add up one more condition. So this should fix the issue. Yeah, it fixed. What we are doing here is that we are trying to figure out whether these particular I comma j are the required indices or not with this condition. But we are also making sure first these I and j are not equal. Then only we are further continuing and checking whether these are the desired ones or not. So that's why it fixed the issue, and it should be sufficient to submit. As you can see, it's accepted. But let's optimize it. Even though it's a brute force solution, so we can still optimize it a bit better. For that, first of all, what we can do is that we are looping through the array in the outer loop from the starting to the ending. Then in the inner loop, again, we are doing the same thing from the starting to the ending, but this is not required because after all, we are looking for combinations, not the permutations. So j can start from I plus 1. As I mentioned, right? It's just a combination. I is pointing to the 0th element. J will be starting from 0th element. Fine. J will be pointing to the first element at some point of time, and we will be considering 2 7 as the candidates, and we will do the validation, and we will store the result in the res. After that, when I comes to the first position, again we no need to run the j from the 0th element because 2 7 is already considered. No need to consider 7 2. Okay, so that's what it will do. And one more thing, we no need to have this check anymore because j will be always I plus 1, so j will never be equal to I. So I just remove that condition, and it also should work perfectly. Yeah, it worked, and it will be a accepted solution. We can try. Yeah, it's accepted. You can see we are progressing in the runtime. So now let's optimize it even more. So here we are looping through the complete combinations, and then after completing the loop, we are returning the solution. But that's not required. We can do an early return as well. That will boost the runtimes. Like here, if you see here, 2 7 are the required solutions. So whenever these 2 7 are met, like we came across these 2 7, then no need to check the other elements after them, like 11 15, because we found our solution and we are sure that there is only exactly one solution. So what we can do is, like, instead of returning after completing the loop, we can return here itself whenever the condition is met, and we are sure that it will only be happening once. Yeah, let's submit it. Yeah, a bit more progress on the runtime. So here, if you can see, we can get rid of this res as well. Not required. Instead, we can directly return the array. So this is the optimized brute force solution. Optimized at the same time brute force. Let's go to the actually optimized solution. We can do that by making use of hash maps. So let's do that. For that, let's do cleanup. And now, yeah, let me explain what hash map is. Like, what we are doing here is that we are looping through the array twice in a nested manner. Then we are trying to check for 2 elements which will satisfy the condition. But that's what we are doing in the brute force. But when we use the hash map, what we will be doing is that we will try to come up with a solution which will be done in one pass. Like, we will go through the array only once. We won't loop through the array in a nested manner. That will boost the runtime before going to the hash map solution. Let's just have an equation. Like, let's say a comma b are the elements that we are looking for. Then a plus b is always equal to the target, because that's what we are going to find out in this solution, right? So a plus b is always equal to the target. So we are given with the target that's already there in the given argument. So if we know the target, and if we are considering a particular element as a, then there will be a specific b for which satisfies the a. Okay, what I mean to say is that if you try to find b, it will be always equal to target minus a. That means, let's say if we are considering 2 as the potential candidate for a, then b would be target minus a. Like, it will be target is 9 minus a is 2. It will be 7. So if we are considering 2 as the candidate a, then candidate b should be 7. Okay. Similarly, if we consider candidate 7, like a 7 as the candidate a, then candidate b should be 2. So like that it will happen. So a and b are complementing each other with respect to the target. So with hash map, what we are doing is we will check if the given element's complement is already present in the hash map or not. If not, we will just record this particular element along with its index. this is if we are not finding the complement. If we find the complement already in the hash map, then we will just return that and the current index as the solution. We will just jump into the code, then it will make more sense. Now let's declare the hash map. Initially the hash map is empty. We are not storing any records in it as of now. Now let's loop through the complete array, right from 0 till the end. So for each element of index I, there will be a complement element which satisfies the given equation that we discussed here. So and it will be true for at least one combination, because we are guaranteed that there will be one exact solution, right? So let's declare the complement. Let's declare it here itself. We can make use of it. So for the I equal to 0, the complement will be target minus nums of I. This will be the complement for nums of I. So we will see if this complement is already present in the hash map. If it's present, we will just return it right away. Complement, like we are getting the record of complement and then the actual index I. So this complement is stored along with its index. So that's why when we get it from the map, it will be returning the index of that complement element. So that index along with the current index will make our solution. So this is in the if condition. If that's not true, that means like the complement was not came across in the hash map so far, then we will just record our current element along with its index. So this should be enough. Let's run it. Sorry about the typos, but it's working. Now let's submit it. Yeah, it's done pretty well.